Welcome. Let's start with a pop quiz. What do Benjamin Franklin, Karl Marx, and the philosopher Hannah Arendt have in common? Anybody? So they all propose this notion of calling humans homo faber, man the tool maker. So we make tools. We alter the environment, and then the tools alter us. And sometimes we lament that. And sometimes these tools have big effects, clothing, cooking, fire, automobiles, computers, and so on. Sometimes they have smaller effects. But it looks like right now we're in a period where we're going to start using more and more tools. So they're going to be ubiquitous throughout our life. And our speaker today, Nicholas Carr, has taken upon himself to investigate this. How do these tools change us? What's for the better, what's for the worse, and can we figure out a way to design them so that we'll live better with them? Welcome to Google, Nicholas Carr.
Thank you. Thanks very much, Peter. And thanks to Ann Farmer for shepherding me through the process and bringing me here, and thanks to Google for hosting these events. I've been to a couple of other Google offices, but this is the first time I've been to the headquarters, so it's exciting. The Googleplex has kind of played a role in my fantasy life for a long time, I realized. Not a weird role. It's kind of a dull fantasy life, but what can I say? So it's good to be here in person. I started writing about technology about 15 years ago or so. So more or less the same time that Google appeared on the scene. And I think it was good timing for Google, and it was also good timing for me because there's been plenty, obviously, to write about. And like I think most technology writers, I started off writing about the technology itself, features, design, stuff like that, and also about kind of the economic and financial side of the business, so competition between technology companies and so forth. But over the years, I became kind of frustrated by what I saw as the narrowness of that view, that just looks at technology or as an economic factor, because what was becoming clear was that computers, as they became smaller and smaller and more powerful and more connected, and as programmers became more adept at their work, computation, the digital connectivity, everything was infusing more and more aspects of everybody's life, at work, during their leisure time. And so it struck me that, as is always true, and as Peter said, with technology, we kind of, technology frames in many ways the context in which we live. And it seemed to me important to look at this phenomenon, the rise of the computer as kind of a central component of our lives, from many different angles. So from see what sociology could tell us, what philosophy could tell us, in all these different ways we can approach an important phenomenon that's influencing our life. And so that, 4 or 5 years ago, I wrote a book called The Shallows that kind of examined how the use of the internet as an informational medium is influencing the way we think and how we're adapting to this kind of not only availability of vast amounts of information, but more and more an actual active barrage of it. And what that meant for our ability to tune out the flow when we needed to and really engage attentively in one task or one train of thought. And as I was writing The Shallows, I also started to become aware of this other realm of research into computers that struck me as dealing with an even broader question, which is what happens to people in their talents, in their engagement with the world, when they become reliant on computers in their various forms to do more and more things. So what happens when we automate not just factory work, but lots of white-collar kind of professional thinking, and what happens when we begin to automate a lot of just the day-to-day activities that we do? We become more and more reliant on computers, not necessarily to take over all of the work, but to become our aid to help shepherd us through our days. And that was the spark that led to The Glass Cage, my new book, which tries to look broadly at the repercussions of our dependence on computers and automation in general, but also looks at the question of, are we designing this stuff in an optimal fashion? If we want a world in which we get the benefits of computers, but we also want people to live full, meaningful lives, develop rich talents, interact with the world in diverse ways, are we designing all of these tools, for everything from robots to simple smartphone apps, in a way that accomplishes both those things? And what I'd like to do is just read a short section from the book that, to me, provides both an example of a lot of the things I'm talking about, a lot of tensions I'm talking about, but also provides sort of a metaphor for, I think, the circumstances we're in the challenges we face. In this section, which comes in the middle of the book, is about the use of computers in automation, not in a city or even in a kind of Western country where there's tons of it, but in a place that looks like this, up in the Arctic Circle, far, far away, where you might think, is shielded from computers and automation, but in fact is not. So let me just read this to you. The small island of Igloolik, lying off the coast of the Melville Peninsula in the Nunavut territory of the Canadian North, is a bewildering place in the winter. The average temperature hovers around 20 degrees below zero. Thick sheets of sea ice cover the surrounding waters. The sun is absent. Despite the brutal conditions, Inuit hunters have for some 4,000 years ventured out from their homes on the island and traversed miles of ice and tundra in search of caribou and other game. The hunter's ability to navigate vast stretches of barren Arctic terrain where landmarks are few, snow formations are in constant flux, and trails disappear overnight has amazed voyagers and scientists for centuries. The Inuits' extraordinary wayfinding skills are born not of technological prowess, they've eschewed maps, compasses, and other instruments, but of a profound understanding of winds, snowdrift patterns, animal behavior, stars, tides, and currents. The Inuit are masters of perception, or at least they used to be. Something changed in Inuit culture at the turn of the millennium. In the year 2000, the US government lifted many of the restrictions on the civilian use of the global positioning system. The Igloolik hunters, who had already swapped their dog sleds for snowmobiles, began to rely on computer-generated maps and directions to get around. Younger Inuit were particularly eager to use the new technology. In the past, a young hunter had to endure a long apprenticeship with his elders, developing his wayfinding talents over many years. By purchasing a cheap GPS receiver, he could skip the training and offload responsibility for navigation to the device. The ease, convenience, and precision of automated navigation made the Inuits' traditional techniques seem antiquated and cumbersome by comparison. But as GPS devices proliferated on the island, reports began to spread of serious accidents during hunts, some resulting in injuries and even deaths. The cause was often traced to an over-reliance on satellites. When a receiver breaks or its batteries freeze, a hunter who hasn't developed strong wayfinding skills can easily become lost in the featureless waste and fall victim to exposure. Even when the devices operate properly, they present hazards. The routes so meticulously plotted on satellite maps can give hunters a form of tunnel vision. Trusting the GPS instructions, they'll speed onto dangerously thin ice or into other environmental perils that a skilled navigator would have had the sense and foresight to avoid. Some of these problems may eventually be mitigated by improvements in navigational devices or by better instruction in their use. What won't be mitigated is the loss of what one tribal elder describes as the wisdom and knowledge of the Inuit. The anthropologist Claudio Aporta of Carleton University in Ottawa has been studying Inuit hunters for years. He reports that while satellite navigation offers attractive advantages, its adoption has already brought a deterioration in wayfinding abilities and, more generally, a weakened feel for the land. As a hunter on a GPS-equipped snowmobile devotes his attention to the instructions coming from the computer, he loses sight of his surroundings. He travels blindfolded, as Porta puts it. A singular talent that has defined and distinguished a people for thousands of years may well evaporate over the course of a generation or two. When I relate that story to people, they tend to have one of two reactions, and my guess is both of those reactions are probably represented in this room. One of the reactions is a feeling that this is a poignant story. It's a troubling story about loss, about something essential to the human condition. And that tends to be the reaction I have to it. But then there's a very different reaction, which is, well, welcome to the modern world. Progress goes on, we adapt, and in the end, things get better. And so if you think about it, most of us, probably all human beings, once had a much more sophisticated navigational sense, internavigational sense, much more sophisticated perception of the world, the landscape. And for most of us, we've lost almost all of that. And yet, we didn't go extinct. We're still here. By most measures, we're thriving. And I think that is also a completely valid point of view. It's true that we lose lots of skills over time, and we gain new ones, and things go on. So in some ways, that your reaction to this is a value judgment about what's meaningful in human life. But beyond those value judgments, I think one thing, or a couple of things that this story, this experience tells us, is how powerful a new tool can be when introduced into a culture. It can change the way people work, the way people operate, the way they think about what's important, the way they go about their lives, in many different ways. And it can do this very, very quickly, overturning some skill or some talent or some way of life that's been around for thousands of years just in the course of a year or two. So introducing computer tools, introducing automation, any kind of technology that redefines what human beings do and redefines what we do versus what we hand off to machines or computers can have very, very deep and very, very powerful effects. And a lot of these effects are very difficult to anticipate. So the Inuit hunters, the young hunters, didn't go out and buy GPS systems because they wanted to increase the odds that they'd get lost and die. And they probably weren't thinking about eroding some fundamental aspect of culture. They wanted to get the convenience, the ease of the system, which is what many of us are motivated by when we decide to adopt some kind of new form of automation in our lives. And when you look at all these unanticipated effects, you can see a very common theme that comes out in research about automation, and particularly about computer automation. And it's something that's been documented over and over again by human factors scientists and researchers, the people who study how people interact with computers and other machines. And the concept is referred to as the substitution myth. And it's very simple. It says that whenever you automate any part of an activity, you fundamentally change the activity. And that's very different from what we anticipate. Most people, either users of software or other automated systems, or the designers, the makers, they assume that actually you can take bits and pieces of what people do, you can automate them, you can turn them over to software or something else, and you'll make those parts of the process more efficient or more convenient or faster or cheaper, but you won't fundamentally change the way people go about doing their work. You won't change their behavior. In fact, over and over again, we see that even small changes, small shifts of responsibility from people to technology can have very big effects on the way people behave, the way they learn, the way they approach their jobs. We've seen this recently with the increasing automation of medical record keeping. As you probably know, we've moved fairly quickly over the last 10 years from doctors taking patient notes on paper, either writing them by hand or dictating them, to digital records. So doctors usually, as they're going through an exam, will take notes, usually going through a template on a computer or on a tablet. And for most of us, our initial reaction is, thank goodness for that, because having records on paper was a pain in the neck. You'd have to kind of enter the same information depending on when you went to different doctors, and God forbid you got sick somewhere else in the country or something, and doctors couldn't exchange, had no way to share your old records. So it makes all sorts of sense to automate this and to have digital records. And indeed, 10 years ago, when we started down this path, the US started down this path, there were all sorts of studies that said, oh, we're going to save enormous amounts of money, we're going to increase patient care, quality of health care, as well as make it easier to share information. And there was a big study by the Rand Corporation that kind of documented all this. They had modeled the entire healthcare system in a computer, and output various things, and this was going to be all to the good. Well, the government went on to subsidize the adoption of electronic medical records to the tune of something like $30 billion since then. And now we have a lot of information about what's really happened, and nothing that was expected has actually played out. And all sorts of things that weren't expected have. For instance, the cost savings have not materialized. Cost has continued to go up, and there's even some indications that beyond the expense required for the systems themselves, this shift may increase healthcare costs rather than decrease them. The evidence on quality of care is very, very mixed. There seems to be no doubt that for some patients, those with chronic diseases that require a lot of different doctors, quality goes up. But for a lot of patients, there hasn't been a change, and there may even have been an erosion of quality in some instances. And finally, we're not even getting the benefits of broad sharing of the records, because a lot of the systems are proprietary and so you can't transfer the records quickly or easily from one hospital to the next or one practice to the next. And now some of these problems are just come from the fact that a lot of software is crappy. And we've rushed to spend huge amounts of money on it. Lots of big software companies that supply this have gotten very wealthy. And doctors are struggling with it, patients are struggling with it. And so some of those things will be fixed at more expense over time. But if you look down lower, you see changes in behavior that are much more subtle and much more interesting and go beyond the quality of the software itself. So for instance, one of the reasons that everybody expected that healthcare costs would go down the assumption was that as soon as doctors can call up images and other test results on their computers when they're in with a patient, they wouldn't order more tests. So we'd see fewer diagnostic tests and fewer costs from those diagnostic tests, a big part of the healthcare system's costs. Actually, exactly the opposite seems to be happening. You give the doctor an ability to quickly order tests and quickly pull up the results. Doctors actually order more of them because they know it's going to be easier for them. And so the quality of the outcomes doesn't go up. We're just seeing more diagnostic tests and more costs. Exactly the opposite of what we expected. You see changes in the doctor-patient relationship. If you've had the experience if you've been around for a while and had the experience of going from a world in which you went into a doctor's office for a physical or whatever, and the doctor paid his or her whole attention to you, to the world of electronic medical records when the doctor has a computer, you know that it intrudes in the doctor-patient relationship. Studies show that doctors now spend, if they have a computer with them, about 25 to 50% of the time during an exam looking at the computer rather than the patient. And doctors aren't happy about that. Patients don't tend to be happy about it. But it's kind of a necessary consequence, at least how we've designed these systems, of this transfer. The most interesting, I'm just going to give you 3 examples of unexpected results, but the most interesting to me is the fact that the quality of the records themselves has gone down. And the reason is that, first of all, now doctors use templates, checkboxes lots of times, and then when they have to put in text describing the patient's condition, rather than dictating it from what they've just experienced or handwriting it, they cut and paste. They cut and paste paragraphs and other stuff from other visits that the patient has had or from visits by other patients that have similar conditions. And this is referred to as the cloning of text. And more of personal medical records consist of cloned text these days, which makes the records less useful for doctors because it has less rich and subtle information. And it also undermines an important role that records used to play in the exchange of information and knowledge. A primary care physician used to get a lot of information, a lot of knowledge by reading rich descriptions from specialists. And now more and more, as doctors say, this is just boilerplate, just cloned text. So we've created the system that eventually will probably have the very important benefit of allowing us to exchange information more and more quickly, more and more easily, but at the same time, we're reducing the quality of the information itself and making what's exchanged less valuable. Now, those are 3 examples of how the substitution myth has played out in this particular area of automation. And they're very specialized, and you see all sorts of these things anywhere you look. But there are a couple of bigger themes that tend to cross all aspects of automation when you introduce software to make jobs easier, to take over jobs. What you tend to get, in addition to the benefits, are a couple of big negative developments. And human factors experts, researchers on this, refer to these as automation complacency and automation bias. Automation complacency means exactly what you would expect. When people turn over big aspects of their job to computers, to software, to robots, they tune out. They begin, we're very good at trusting a machine, and certainly a computerized machine, to kind of handle our job, to handle any challenge that might arise. And so we become complacent, we tune out, we space out. And that might be fine until something bad happens, and we suddenly have to re-engage with what we're doing, and then you see people make mistakes. Everybody experiences automation complacency in using computers. A very simple example is autocorrect for spelling. When people have autocorrect going, when they're texting or using a word processor or whatever, they become much more complacent about their spelling. They don't check things, they let it go. And then most of people have had the experience of sending out a text or an email or a report that has some really stupid typo in it because the computer misunderstood your intent, and that causes maybe a moment of embarrassment. But you take that same phenomenon of complacency and put it into an industrial control room, into a cockpit, into a battlefield, and you sometimes get very, very dangerous situations. One of the classic examples of automation complacency comes in the cruise line business. A few years ago, a cruise ship called the Royal Majesty was on the last leg of a cruise off New England. It was going from Bermuda, I think, to Boston. Had a GPS antenna that was connected to an automated navigation system. The crew turned on the automated navigation system and kind of became totally complacent. Just assumed, okay, everything's going fine. Hey, the computer's plotting our course. Don't have to worry about it. And at some point, the antenna, the line to the GPS antenna broke. And this was way up somewhere, nobody saw it. And nobody noticed. There were kind of increasing environmental clues that the ship was drifting off course. Nobody saw it. At one point, a mate whose job it was to watch for a locational buoy and report back to the bridge that, yeah, we passed this as we should have. He was out there watching for it, and he didn't see it. And he said, well, it must be there because the computer's in charge here. I just must have missed it. So he didn't bother to tell the bridge. He was embarrassed that he had missed what must have been there. Well, hours go by, and ultimately the ship crashes into a sandbar off Nantucket Island, many miles off course. Fortunately, no one was killed or injured that bad, but there was millions of dollars of damage. And it kind of shows how easily, if you give too much responsibility to the computer, the people will tune out, and they won't They won't notice things are going wrong, or if they do notice, they might make mistakes in responding. Automation bias is closely related to automation complacency, and it just means that you place too much trust in the information coming from your computer, to the point where you begin to assume that the computer is infallible, and so you don't have to pay attention to other sources of information, including your own eyes and ears. And this, too, is something we see over and over again when you automate any kind of activity. A good example is the use of GPS by truck drivers. Truck driver starts to listen to the automated voice of the GPS woman telling him, where to go and whatever, and he or she begins to ignore other sources of information like road signs. So we've seen an increase in the incidence of trucks crashing into low overpasses as we've increased the use of GPS. And in Seattle a few years ago, there was a bus driver carrying a load of high school athletes to a game somewhere, 12-foot-high bus, approached a 9-foot-high overpass, and there were all these signs along the way, danger, low overpass. There were even signs that had blinking lights around them. He smashes right into it. Luckily no one died. A bunch of students had to go to the hospital. The police said, what were you thinking? And he said, well, I had my GPS on and I just didn't see the signs. So we ignore or don't even see other sources of information. In another very different area, back to healthcare, if you look at how radiologists read diagnostic images today, most of them read them as digital images, of course, but also there's now software that is designed as a decision support aid and analytical aid, and what it does is it gives the radiologist prompts. It highlights particular regions of the image that the data analysis, past data, suggests are suspicious. And in many cases, this has very good results. The doctor focuses attention on those particular highlighted areas, finds a cancer or other abnormality that the doctor may have missed, and that's fine, but research shows that it also has the exact opposite effect. Doctors become so focused on the highlighted areas that they only pay cursory attention to other areas and often miss abnormalities or cancers that aren't highlighted. And the latest research suggests that these prompt systems, which as you know, are very, very common in software in general, these prompt systems seem to improve the performance of less expert image readers on simpler challenges, but decrease the performance of expert readers on very, very hard challenges. The phenomena of automation complacency and automation bias points to, I think, an even deeper and more insidious problem that poorly designed software, poorly designed automated systems often triggers. And that is that in both of those cases, with complacency and bias, you see a person disengaging from the world, disengaging from his or her circumstances, disengaging from the task at hand, simply assuming that the computer will handle it. And indeed, the computer has been designed, whatever system we're talking about, has been designed to handle as much as the chore as possible. And what happens then is we see an erosion of talent on the part of the person. Either the person isn't developing strong, rich talents, or their existing talents are beginning to get rusty. And the reason is pretty obvious. We all know, either intuitively or if you've read anything about this, how we develop rich talents, sophisticated talents. It's by practice. It's by doing things over and over again, facing lots of different challenges in lots of different circumstances, figuring out how to overcome them. That's how we build the most sophisticated skills and how we continue to refine them. And this crucial element in learning in all sorts of forms is often referred to as the generation effect. And what that means is if you're actively engaged in some task, in some form of work, you're going to not only perform better, but learn more and become more expert than if you're simply an observer, simply passively watching as things progress. And the generation effect was first observed in this very simple experiment involving people's ability to expand vocabulary, learn vocabulary, remember vocabulary. And what the researchers did, this was back in the 70s, is they got two groups of people to try to memorize lots of pairs of antonyms, lots of pairs of opposites. And the only difference between the two groups was that one group used flashcards that had both words spelled out entirely, hot, cold. The other had flashcards that just had the first word, hot, but then provided only the first letter of the second word, so C. And what they found was that, indeed, the people who used the full words remembered much fewer of the antonyms than the people who had to fill in the second word. The reason, there's a little bit more brain activity involved here. You actually have to call to mind what this word is. You have to generate it, and just that small difference gives you better learning, better retention. A few years later, some other researchers, some other professors in this area, realized that actually this is kind of a form of automation. What this does, giving the full word, in essence automates the work of filling in the word. And they explain this as, in fact, a phenomenon related to automation complacency. You might be completely unconscious of it, but your brain is a little more complacent. It doesn't have to work as hard in this mode, and that makes a big difference. And it turns out that the generation effect, it kind of explains a whole lot about how we learn and develop skill in all sorts of places. It's definitely not just restricted to studies of vocabulary. You see it everywhere. If you're actively involved, you learn more, you become more expertise. If you're not, you don't. And unfortunately, with software, more and more, the programmer, the designer, actually gets in the way of the generation effect, and not by accident, but on purpose, because of course, the things we tend to automate, the things we tend to simplify for people are the things that are challenging. You look at a process, you look where people are struggling, and that is both often the most interesting thing to automate, but also the place that whoever's paying you to write the software is encouraging you to do, because it seems to create efficiency, it seems to create productivity. But what we're doing is designing lots of systems, lots of software that actually deliberately, if you look at it in that sense, gets in the way of people's ability to learn and create expertise. There was a series of experiments done beginning about 10 years ago by this young cognitive psychologist in Holland named Christoph van Nimwegen. And he did something very interesting. He got a series of different tasks. One of them was solving a difficult logic problem. One of them was organizing a conference where you had a large number of conference rooms, large number of speakers, large number of time slots, and you had to optimize how you put all those things together. So a number of tasks that had lots of components, required a certain amount of smarts, and required you to work through a hard problem over time. And in each case, he got groups of people, divided them into two, created two different applications for doing each of these. One application was very bare bones. It just provided you with the scenario, and then you had to work through it. The other was very helpful. It had prompts, it had highlights, it had advice, on-screen advice. When you got to a point where you could do some moves, but you couldn't do others, it would highlight the ones you could do and gray out the ones you couldn't. And then he let them go and watched what happened. Well, as you might expect, the people with the more helpful software got off to a great start. The software was guiding them, helping them make their initial decisions and moves. They jumped out to a lead in terms of solving the challenges. But over time, the people using the bare bones software, the unhelpful software, not only caught up, but actually, in all the cases, ended up completing the assignment much more efficiently, made much fewer incorrect moves, much fewer mistakes. They also seem to have a much clearer strategy, whereas the people using the helpful software kind of just clicked around. And finally, Van Nimwegen gave them tests afterwards to measure their conceptual understanding of what they had done. People with the unhelpful software had a much clearer conceptual understanding. Then, 8 months later, he invited, for just the logic puzzle group, he invited all the people who did that back, had them solve the problem again. The people who had 8 months earlier used the unhelpful software solved the puzzle twice as fast as the people who used the unhelpful software. The more helpful the software, the less learning, the weaker performance, the less strategic thinking of the people who used it. Again, this underscores a fundamental paradox that people face, people who develop these programs and people who use them, where our instinct to make things easier, to find the places of friction and remove the friction, can actually lead to counterproductive results where you're eroding performance and eroding learning. So if you look at kind of all the psychological studies and the human factor studies of how people interact with machines and technology and computers, and you also combine it with psychological understanding of how we learn, what you see is that there's a very complex cycle involved. If you have a high degree of engagement with people, if they're really pushed to engage with challenges, work hard, maintain their awareness of their circumstances, you provoke a state of flow. If you've read Csikszentmihalyi's book Flow or are familiar with it, we perform optimally when we're really immersed in a hard challenge, when we're stretching our talents, learning new talents. That's the optimal state to be in. It gives us more skills, pushes us to new talents, and it also happens to be the state in which we're most fulfilled and most satisfied. Often people have this feeling that if they were relieved of work, relieved of effort, they'll be happier. Turns out they're not. They're more miserable. They're actually happier when they are working hard, facing a challenge. And so this sense of fulfillment prolongs your sense of engagement, intensifies it, and you get this very nice cycle. People are performing at a high level, they're learning talents, and they're fulfilled. They're happy, they're satisfied, they like their experience. All too often you stick automation into here, particularly if you haven't thought through all of the implications, and you break this cycle. Suddenly you decrease engagement and all the other things go down as well. You see this today in all sorts of places. You see it with pilots whose jobs have been highly, highly automated. Automation has been a very good, very positive development for 100 years in aviation. But recently, as pilots' role in control of the aircraft, manual control, has gone down to the point where they're maybe in control for 3 minutes during a flight, you see problems with the erosion of engagement, the erosion of situational awareness, and the erosion of talent. And unfortunately, on those rare occasions when the autopilot fails for whatever reason, or there's very weird circumstances, you increase the odds that the pilots will make mistakes, sometimes with dangerous implications. So why do we go down this path so often? Why do we create computer programs, robotic systems, other automated systems that instead of raising people up to their highest level of talent, highest level of awareness and satisfaction, has the opposite effect? I think much of the blame can be placed on what I would argue is the dominant design philosophy or ethic that governs the people who are making these programs and making these machines. And it's what's often referred to as technology-centered design. And basically what that means is the engineer or the programmer or whatever starts by asking, what can the computer do? What can the technology do? And then anything that the computer or the technology can do, they give that responsibility to the computer. And you can see why this is what engineers and programmers would want to do, because that's their job, to simulate or automate interesting work with software or with robots. So this is a very natural thing to do. But what happens then is what the human being gets is just what the computer can't do, or what we haven't yet figured out to have how the computer can do it. And that tends to be things like monitoring screens for anomalies entering data, and oh, by the way, you're also the last line of defense, so if everything goes to hell, you've got to take over and get us out of the fix. Those are things that people are actually pretty bad at. We're terrible at monitoring things that we're waiting for an anomaly. You can't focus on it for more than about a half an hour. Entering data, becoming the kind of sensor for the computer is pretty dull job in most cases. And if you set up a system that ensures that the operator is going to have a low level of situational awareness, then that is not the person you want to be having as the last line of defense. The alternative is something called surprise human-centered design, where you start by saying, what are human beings good at? And you look at the fact that there's lots of important things we're actually still much better than computers at. We're creative, we have imagination, we can think conceptually, we have an understanding of the world, we can think critically, we can think skeptically. And then you bring in the software, you bring in the automation to aid the person in exploiting those capabilities, but also to fill in the gaps in the flaws that we all have as human beings. We're not great at processing huge amounts of information quickly. We're subject to biases in our thinking. You can use software to counteract these or to provide an additional set of capabilities. And if you go that path, you get both the best of the human and the best of the machine or the best of the technology. So some of the ideas here are very, very simple. For instance, with pilots, instead of allowing them to turn on total flight automation once they're off the ground and then not bother to turn it off until they're about ready to land, you can design the software to give control back to the pilot every once in a while at random instances. And just when you know that you're going to be called upon at some random time to take back control, that improves people's awareness and concentration immeasurably. It makes it less likely that they're going to completely space out. Or in the example of the radiologist, and this goes for examples of decision support or expert system or analytical programs in general, one thing you can do is instead of bringing in the software prompts and the software advice right at the outset, you can first encourage the human being to deal with the problem, to look at the image on his or her own, or to do whatever analytical chore is there, and then bring in the software afterwards as kind of a further aid, bringing new information to bear. And that, too, means you get the best of both people. Unfortunately, we don't do that, or at least not very often. We don't pursue human-centered design. And I think it's for a couple of reasons. One is that we human beings, as I said before, are very eager to hand off any kind of work to machines, to software, to other people, because we are afflicted by what psychologists term miswanting. We think we want to be freed of labor, freed of hard work, freed of challenge. And when we are freed of it, we feel miserable, we feel anxious, we get self-absorbed, and actually our optimal experience comes when we are working hard at things. So there's something inside of us that is very eager to get rid of stuff, even if it's get rid of effort, even if it's not in our own benefit. And then the other reason, which I think is one that's even harder to deal with, is the pursuit of efficiency and productivity above all other goals. And you can certainly see why hospitals who want the highest productivity possible from radiologists would be averse to saying, well, we'll let the radiologist look at the image and then we'll bring in the software, because that extends the time that a radiologist is going to look at this, and that's true of any of these kind of analytical chores. And so there's this tension between the pursuit of efficiency above all other things and productivity and the development of skill, the development of talent, the development of high levels of human performance, and ultimately the sense of satisfaction that people get. And I think in the long run, you see signs that that begins to backfire. Toyota earlier this year announced that it was replacing some of its robots in its Japanese factories with human beings Because even though the robots are more efficient, the company has struggled with quality problems. It's had to recall 20 million cars in recent years. And not only is that bad for business, but Toyota's entire culture is built around quality manufacturing, so it erodes its culture. So by bringing back human beings, it wants to bring back both the spirit and the reality of human craftsmanship, of people who can actually think critically about what they're doing. And one of the benefits it believes it will get is that it will be smarter about how it programs its robots. It will be able to continually take new human thinking, new human talent and insight, and then incorporate that into the processes that even the robots are doing. That's a good news example, but I'm not going to oversimplify this or lie to you. I think this tension between placing efficiency above all other things, immediate efficiency, is a very hard instinct, very hard economic imperative to overcome. But nevertheless, I think it's absolutely imperative that everyone who designs software in robotics and all of us who use them are conscious of the fact that there is this trade-off, and that technology isn't just a means of production, as we often tend to think of it. It really is a means of experience, and it always has been. Since the first technologies were developed by our distant ancestors, technology at its best, tools at their best, bring us out into the world, expand our skills and our talents, make the world a more interesting place, and we shouldn't forget that about ourselves as we continue at high speed into a future where more and more aspects of human experience are going to be offloaded to computers and to machines. So thank you very much for your attention. Thank you.
One thing that immediately sprung to mind with most of your examples is that they seem like examples of poor automation. And I'm wondering if you could say whether you feel that there could be or are already any sufficiently flawless technologies that we don't have to worry about the sort of problems you're describing.
I think in all instances you have to worry about them. I agree with you that a lot of these problems are not problems about automation per se. Nobody's going to stop the course of automation. You can argue that the invention of the wheel was an example of automating something, and I don't think any of us regrets that. But I do think it's often unwise design decisions or unwise assumptions that come in. But as to the question of whether we will create infallible automation, I don't think so. I mean, often you get this point of view, and it seems to be quite common in Silicon Valley, if I can say that, people are only going to be a temporary nuisance in a lot of these processes. We're going to have fully self-driving cars. We're going to have fully self-flying planes. We're going to have kind of fully analytical systems, big data systems that can pump out the right answer. We won't have to worry about it. I don't think that that's actually going to happen. I mean, it might happen eventually. It's very, very difficult to remove the human being altogether. And so to me, what that means is, okay, fine, you can pursue that as some ideal, total, flawless automation. But in the meantime, we live and work in the present, not in the future. And for the foreseeable future, in all of these processes, there are going to be people involved, and there are going to be computers involved. And instead of just saying, let's put the computer's interests before the person's, I think the wise way is, as I said, to go with a more human-centered design that realizes and starts with the assumption that the human being is going to play an essential role in these things for as long as we can imagine, or as long as we can foresee. And so we better design them to get the most out of the person as well as the technology. Peter.
Thanks, that was great, and I certainly agree with the idea of focusing on the human-centered design. I want to make one quick comment and then a question. I noticed on your hot-cold thing, there was another researcher who took passages from books and presented them, and then multiple-choice quiz or whatever, And then they took the same passage and deleted a key sentence. And people did better understanding the point then. But somehow no authors are willing to have the guts to do that. So will you be that author to delete the important sentences from your book and make the reader engage more and therefore learn better?
If any of you buy my book, I would be happy to take a Sharpie and erase certain sentences and you can get the full benefit. But I will take that under advisement for future books.
And then a question. I'm interested in the difference between automation complacency and authority complacency. So you see a lot of, these incidents reports, and there'll be some underling who said, I kind of noticed something was going wrong, but the surgeon or the pilot or the CEO seemed so sure that I didn't want to say anything.
Yeah.
And that has nothing to do with automation. It's just authority.
I think that's probably pretty much exactly the same phenomenon. And I actually do think it probably has something to do with automation because you could say that automation complacency comes when the computer or the machine takes the role of authority. So the person defers to it, and I think that's certainly one way to interpret a lot of the findings, that you don't question the machine, you don't question the automation in a way that would be wise. So I think they're probably, I think complacency has been a problem since long before computers came around for people, for those reasons and others, but we've created a new way to generate the same phenomenon. Yeah.
I'm curious to ask if you know much research about what percentage of time or experiences we need to keep manual in order to make sure that the skills don't fade away. So and if you have any thoughts on how much this transfers from domain to domain. So in the wayfaring example of the Inuit, right? You might say you could use GPS, 80% of the time, but you got to do 20% of it manually to keep your skills up. And maybe airline pilots, have the other examples that you cited. Do you know how much this has been studied and how much it might vary from domain to domain?
As far as the second question, I don't know. I mean, I don't know any rules of thumb either in specific domains or that cross domains. I can say, though, that there's enormous amounts of research that's been done in aviation. I mean, because of the fact that the risk is so high and lots of people can die and lots of money can be lost, ever since computerization of flight began back in the 70s, there's been, whether it's NASA or the FAA or universities, there have been tons of research. So my guess is that there has been, an examination. There probably have been tests where you have different levels of automation and manual control and comparing different levels of performance. I didn't come across those specific, studies in my work, but my guess is that would be an obvious thing that would have been done. So my guess is, so I'm saying in aviation, there's probably at least some sense of, how much, at what point does performance start to drop off or start to drop off dramatically because you've turned over too much responsibility to the machine. Whether that would also translate into the same kind of percentages in different domains, I don't know. Yeah.
Thanks for coming. The talk was really interesting.
Thank you.
In your talk, you pointed out that technology always comes with trade-offs, and it's hard to disagree with that. But I'm wondering about the title of your book. The title is The Glass Cage, and that seems like to call technology a glass cage seems like a much more negative assessment than merely saying that it comes with trade-offs. So I'm wondering if you could say what motivates this title.
Well, the title is a reference back to pilots' experience. Since the 70s, pilots and others in the aviation business have referred to cockpits as glass cockpits. And it's because increasingly they're wrapped with computer screens. If you look in a modern airline, a modern passenger jet, it's insane amounts of computer screens, all sorts of input devices and stuff. One aviation expert refers to the cockpit now as a flying computer. So in one sense, it's just kind of a play on that, because what I argue is that we can learn a lot from pilots' experience as we enter into a world that essentially more and more of us are going to be living inside a glass cockpit. We're going to be looking at monitors to do more and more things. We're already there, some would argue. And I do think that what a lot of examples of computer automation tell us is that the glass cockpit can become a glass cage. That if we design it to be kind of the primary or the essential way we interact with the world, then it cuts us off from other sources of learning and information that might be absolutely essential, but we're so focused on what the computer is telling us, we lose that. So, I mean, it is intended to be a little bit ominous that we can either get trapped in this glass cage or we can use technology in a more, what I think is a more humane and more balanced way.
Thanks for that question. And on that note, please join me in thanking Nicholas Carr for coming to Google.
Thank you. Thanks a lot.